Welcome to qnawire.
The angular momentum of the Earth around the Sun, considering the Earth as a point particle, is given by L is equals to the mass of the Earth times the velocity times the radius of the orbit. And now remember that for a circular movement, we are approximating the orbit of the Earth as a circular movement. The velocity is given by v is equals to omega times the radius of the orbit. So we can write L as the mass of the Earth times omega times r orbit squared. But now remember that this omega is related to the frequency of the orbit as follows. The omega is the angular frequency. The frequency, the absolute frequency, is related to omega by omega is equals to 2 pi times that absolute frequency. Therefore, we can write L as the mass of the Earth times omega, not omega anymore, the mass of the Earth times 2 pi times the frequency times the radius of the orbit squared. But now remember that the frequency is just given by the inverse of the period. So we have this relation, and therefore the angular momentum of the Earth is given by the mass of the Earth times 2 pi times the radius of the orbit squared divided by the period of that movement. Now note that we know the period of those rotations. The period is just equals to 1 year. So the period of an orbit is 1 year. And then remember that from quantum mechanics we have L equals to h bar square root of L times L plus 1. Then we can equate h bar times the square root of L times L plus 1 as being equals to the mass of the Earth times 2 pi times the radius of the orbit squared divided by the period of the orbit. Now note that the value for L will be a very big one, so we can approximate L plus 1 as being almost equals to L. Then this factor here inside the square root would become just L squared, and the square root of L squared is just L. So we can then write L as being equals to the mass of the Earth times 2 pi times the radius of the orbit squared divided by h bar times the period of that orbit. Finally, plugging in the values, we have L is equals to 5.98 times 10 to 24 times 2 pi times 1.496 times 10 to the 11 squared, and this is divided by 1.055 times 10 to minus 34 times 1 year. But 1 year has 12 months, and each month has 30 days, and each day has 24 hours. Each hour has 60 minutes, and each minute has 60 seconds. So this big quantity here, 1 times 12 times 30 times 24 times 60 squared, is the number of seconds in a year. By proceeding with this calculation using a calculator, we get a orbital quantum number of approximately 2.56 times 10 to 74. Now for the next item, we note that the number of possible orientations for that movement of the orbit of the Earth is equals to the number of possible values for ML. So for the next item, we have that the number of possible orientations is equals to the number of possible values for ML. And remember that ML can be anything, any integer number that is in between minus L and L. So the number of possible values for ML is equals to 2L plus 1. Then the number of possible orientations for that plane of the orbit is equals to 2L plus 1. But L is very big, then 2L plus 1 will be approximately 2L. Therefore, that number of orientations is equals to 2 times 2.56 times 10 to 74. And this gives us an approximate number of orientations for the plane of the orbit as 5.12 times 10 to 74.